Good morning, everyone. I'm Kajal Patel from IITDS Computer Engineering Department, Parallel University. And now today we have expert that his is a Neil Shah, and his designation web system architect. Currently, is working in a Canopy Growth, and he is completed his B and ME from the Parallel University, and currently he is uh, doing the PhD from Latte University. Now his experience of 7+ years in the industry. Plus he is also doing the research experience in a real-time data analysis system. Design such as a leader, camera, web analysis, social media, healthcare analysis. Has also experience in implementing the statistical and predictive real-time or offline system using in a Python. Then extensive experience in a large-scale ETL process. He has also experience in handling and modeling the database for million data with terabyte of data and developing the action reactive Python system distributed architecture and multiple hardware connected system. So I would like to now Mr. Neil your presentation and over to you.
Thank you so much, Komal. And first of all, good morning, everyone. I would like to thank you for Parallel University for arranging such a nice event and sharing my knowledge with everyone. Thank you, Hathal ma'am, as well as the Komal ma'am and all the coordinators for managing and coordinating this event. And welcome everyone who is joining live on a Facebook. So let me start uh, with understanding how what is going on in this industry when we talk about the real-time data analytics and what is the real time, how that thing works and where this industry is going on right now. So if you see all the big companies are growing repeatedly focus on the data. They are getting more the data, collecting more data, and they're trying to understand what their data means is. And there are many types of data which stores from generations, like from years. Like if we talk about the general motors, they have a data for more than a 60 years. If we talk about a Ford, they have more than a 50 years old data. We talk about Mercedes and other stuff, they have more than a 70 or 80 years old data. The question comes in how they want to understand that data. When we talk about the health, the oldest democracy in the world is US. They have a data more than 150 years old. Canada has a 60 years old data. The question comes, what we can do with this with those data, and that is that do we have the efficient system which can fetch all the data in a real time, the older data, understand the older data, and try to understand the newer data which comes in a real time. This thing. So this specific presentations, what we are trying to do is that we try to understand through a social media how's the nation's health is. So we basically focus this the presentations will be is based on the consumption of calories and use of calories, like how many calories they eat or how many calories they burn through different activities like running, reading, exercising, gymming, and many others, right? So the question is that a efficient source? If it is an efficient source, how much data we need? If we know how much data we need, what can be the procedure to resolve that type of issues and to find out the information which can be trustable, which can be alternative what currently we have. So these presentations will try to answer those type of questions, like what is the motivation behind that thing and what we are trying to solve and where we reach and what will be the future goal will be, where we want to reach, uh, to make sure that system can replace what we have in a current uh, in a current scenarios, right? So let's start with the presentation then. The presentation is mostly about the framework for social media data analytics using Elasticsearch, Kibana, Kibana using a Twitter database. So it's not a small database. We will go through it, how this thing works. Let's start with that thing, like why we want to do that thing. That always comes like what is the motivations behind doing this research or finding the solution is. The question comes in a very simple way. The public health is becoming a very primary concerns throughout the government around the world. Like even in a corona right now, what we are facing and what we are seeing is that all the like the public around the globe are more concerned about the public health, how the health is going on, how government is working to improve the health systems, how we can monitor the scenarios and all the transmissions about not about the viruses but about the daily activities and all that stuff, and what will be the better way to do that thing. Traditionally what government do is that they use the door-to-door surveys to find out what is going on, like in corona, right? Like they go to door and ask that, like did you have a vaccine or did you check out, or they motivate you to get the vaccinations and do the corona testings and many other things. But this is what we see right now. But even in the previous things, for diabetics, for HIV, for AIDS, and many other health bimari, how they uh, find all the answers is that they do a door-to-door surveys in a larger scales to understand what is the nation's health right now on a very larger scale. So to decide what will the policies, for example, people see more diabetes or more blood pressure cases, nations need to know that okay, this is the issue what is going on right now, and it is increasing. So after 5 years we may have this many number of patients or this type of issues in a national level. So what the policies we want to decide. So to make that type of to understand those questions, to give the answers, like if you want to decide the health policies, what will be the future issues based on a current scenarios. That's a really big questions. And what we try to do is that, is there any better way than a door-to-door survey? It's a traditional way of doing the stuff. And this is the core motivations behind this type of research. Specifically, this research is the core motivation. So uh, so let's start with other information, like what is the sub motivations for that, like the information which is limited and sometimes it's like a long time to collect, right? Like when even we don't do a door-to-door surveys, when we try to collect the information from the doctors, local hospitals, through the number of cases and their understanding of the small geographical area, it still take times, it's still limited, right? Our approach is try to solve such a problem through the advancement of natural language processing algorithms and a large scale data analytics. So let's start with why we use specific type of data. First, let's try to understand how internet and the social media penetrate our society. Here in this specific research, we talk about the Canadian society. So the yearly growth of social media users in Canada is almost twice the growth of internet users they have, which is 13% average. It is the growth number, which is quite surprising. Now, the second number is the Canada's the population is 36.79 million in 2018, based on the government data. And among them, there are 33.05 million users, which are the internet users. It is basically 90% of the total populations, but if you see the eligible population, which is very interesting, right? So when we say eligible population is that we remove the childrens and a certain number of age who are larger than 70 or 80, right? Who may not use the internet more frequently, or who may not have internet connections. Smaller children definitely not have an internet connection. So if we remove it, the penetration is almost 96 or 97% in a total populations, which is very high. And if you see the social media penetration is almost 68% of total populations, which is 25.56 millions. But if we compare this number with the number who are the eligible or who should or who may use a social media, are between the age group from 12 to 60. And if you see that, if you see the age number, and if you remove all the things, the penetration is almost 92 or 93% if we remove the all the ages of higher ages and early childhood ages number. So that is very interesting. Like 95 or 96 eligible population have an internet, and out of 95 or 96%, 92% have a social media presence in an internet space. So that is very interesting number. So even a Twitter, like in terms of Canada, Twitter has the most significant amount of activity at almost 7.2 million monthly active users out of 36.79 million population of Canada, which is extremely high. It's almost third part of Canada is active on a Twitter in a monthly basis. So let's understand the second thing. If they are the active user, how much time they spend even on the internet? And the answer is 6 hours. The average Canadian spends approximately 6 hours on their time or daytime on the internet. So that is that's where the real goal comes in. It means that users share their activity, what they are doing during a real life on a social media. So basically, they are saying what they are doing, what their activity is, what they may like about the food, what they may not like about the food. They went to the restaurants or many other type of things. So, like to solve this problem, we basically divide everything in a two part. One is to create an infrastructure or a pipeline, how we want to process the data, and the second is that when we get the data, what will be the algorithm and what will be the mathematical statistics we're going to use. So in this presentation, we not go through all the complex mathematical stuff, but we do try to understand what we did to solve that specific issue. So let's start with like why even we need it. So let's try to understand that thing, why we need a specific infrastructure or specific kind of pipelines for this type of research. So the first thing we need to understand is that what is the real time means. When I say real time means is that real time has a different sense of meaning in a different sense of scenarios. For example, if I am doing a constructions, I need to update maybe every day how much progress happens. If vaccination is going on, I may need to understand every hour how many vaccines happens. But if I am a security guy, I need to understand each and every second what happened. So, and all three systems are the real-time systems in their own perspectives, right? So what we try to understand is that what is the real-time means in this specific health scenario, and how we want to try to describe that thing. So when we say how real-time the system is, it's a like a security type of systems, like it's real time, like every second the results got updated based on a data, but all the analytical result comes every day or every week based on a configurations how we want to do it. But as PD as it is, we can do it every week, every day. So let's start with like what we do. So we describe how we want to collect the data. We also described how we want to pre-process all the data, and we want the whole process is a one-time process. We don't want a process that we take the data, store it somewhere, the process it, and then use the clean data, which is a standard data analytics pipeline. But when we talk about the data which is generating a billion tweets in a year, and we wanna do that thing in efficiently where we have a 10,000 tweets every seconds in a one province, that is a crazy number. And to process that amount of data, we have to do all the stuff in a one time process. We don't want to collect the data and in After Effects we want to process the data. So what we try to do here is that let's collect the data and the pre-process the data at the same time before storing that data in a final database. So here what we do is that efficiency of continuous data fetching, like through a non-SQL and a relational database. So we basically try to use that type of things like NoSQL and relational database to store the final processed data informations, right? So let's understand how the systems look like in a very abstract level. It's not like a nut and bolt of the systems, I can say, but it is like how it is looking in a use right now in a very larger and abstract view. So we get the raw data, and then we do a data cleaning. Just for an example, we get the Twitter data in a bulk. Let's talk about if we are using if you are familiar with the Twitter API, and if like we have a paid systems, but many other individual contributor don't have it. For example, if you're using a free Twitter API, they give a random 1,000 tweet per second, right? So for example, let's consider that 1,000 tweets data, and now we put that thing in a data cleaning. So data cleaning and data storing happens between that. Now, after the data cleaning happens, we try to extract the features from that data for our machine learning. When we do that, we try to do a TF-IDR. So this is a specific machine learning algorithm, but what exactly it does is that it identifies that that tweet is related to a food or not. Um, so when we talk about English, so we have a specific uh, phrases, right? Which has a different meaning, right? Like it's like an apple on my head. So it has a different meaning. It's related to Newton, that you get an idea, right? But it is when we do a classical machine learning algorithms, NLP algorithms, it does not understand what will be the larger understanding of that specific sentence, because a combination of word make it a different meaning than an individual word. So that specific functionality and algorithm, like AI algorithm, which decide that that tweet is related to food or not. And after that it go to the classical ML model, get all the data specific features, like what is the, if it is a tweet regarding a food, let's extract the word food, for example apple, chole bhature, or ringan ka bharta, or anything else, right? And we from that thing we try to calculate the calories, like how much what is the calorie of butter chicken, or what is the calorie of apple, what is the calorie of spinach or anything else. And then based on that information we try to visualize the stuff, like what is going on a larger scales, and how it looks at the national level. So we will definitely understand what is the result with the government results what we have. Let's understand how it perform, right? We created the system. The question always comes in is that how good these systems are. So we definitely test this system. So we use Elasticsearch to analyze more than a 250 million out of a 1 billion tweets scrapped between December 2017 to May 2018 using Twitter API. So when we talk about 250 million, is almost 3 terabyte of data, and we talk about the billions is around 10 terabyte of data. If we scramble it up and store in an optimized way. So what we do is that we optimize the Elasticsearch in a way that it processes the data in specific manner. Even we make sure the JSON depth of the data is on a single level. So one interesting question here comes in: why even we have to do this thing? So let's see how it basically looks first. So original tweet has a tweet user ID name, and many other things, right? And what we do in a data structure is that just put the ID or a name on a very single streamline level. Why even do that thing? So we need to understand when any JSON scraper works, it always go to a level by level by level. The question comes in that any more level it goes, the complexity increase by n. For example, if it has a n number of depth, now we have a n number of more complexity, which is called the worst case scenario. Big O complexity of n into n means n raised to n, which is really a one worst kind of complexity. What we try to do is that let's don't get all the data. Let's just get the data what is necessary, put that thing in a single structures, and try to reduce the complexity from big O and n raised to n to big O and log n. So that's the idea, and that's the reason why we uh, even optimize the JSON format in a specific way. So that's why we try to optimize the format. The second thing we do is the query processing and indexing. So we need to understand, like, we can't store that data in a one single CPU. It's not possible. It should be in a data center. It should be in a distributed manner. It can be divided into um, multiple storage SSDs and multiple processing units. So the question comes in that what is the best way? How much data we want to store, that thing. So to understand and to find out what will be the optimized thing, what we did basically is that uh, we understand how Elasticsearch works. So we go to the JVM, try to understand which JVM they're using, and we figure it out that okay, the maximum index size what they support is less than 20 GB. So basically, we can't have a shared the number of shares, which is the number of distributed storage in this specific format, like size of index in GB divided by 50. We don't have more than that's how we divided how many shards we want and how we want to distribute the data in a multiple servers. We just increase our performance at the larger level. So as I explained before, this is the updated tweet size. So the question is that how good it performs when I try to search a specific keyword. So we did that type of thing. So we search for a pizza keyword from all the tweets, and you can see the number of tweets are really large amount of tweet side. So uh, we figured out that we get all the data from that many hits tweets in a 0.013 seconds, and we got these visualizations in 0.013 seconds. So it just proved that the systems how we do it, it's more um, it's more stable, it's performing well, and it's giving the results what we want. So this is other kind of results, like we search for other keyword based on a language. Here we try to do the same thing based on a source, like it's coming from the iPhone or API or a TweetDeck or a web client or Android and others, and any many other things. After that, uh, this is the infrastructure what we created. Now the question is that how we try to understand that type of things. So I'm not going in very deep relating the related work and of which research papers we read and all this stuff. But it's a really good information if you want to go through later. But let's try to understand what is the current limitations through many other research. What we figure out more than 100 research papers. So we figured out that what they are using is not they are not going based on their geographic locations, right? They have a very limited food data sets. They just have a 451 food phrases only. Just consider how many foods we have, like for example, if we have to say butter chicken, or if I have to say green tea or Kashmiri kawa, how that thing will be understand, right? Like if I express that thing on a Twitter or any other social media source. So that's why question comes in. We don't have a food data set. So basically, the first thing we encounter or the first thing we face is that we don't have a database. We don't have a data or a food to count the calories and other things to give them a result. So that's one. That's a very big challenge what we face that time. The second thing is that another limitation is that Twitter account may talk about the food or activity in a very metaphorical perspective, like food words may be commonly used in idiomatic expressions, right? Because of the English language nature. And there are different cases, for example, bring home the bacon, right? Or a cry over a split milk, or a cup of tea, right? A cup of tea means it's very easy, right? Bring home the bacon means surprise or get a good food or a grocery or something, that kind of thing. But they are not talking about the food. Like cup of tea is just means like it's very easy. It's like a easy task. The question is that how we want to understand that thing. So that's where our new algorithms and everything comes in a picture. So, as I told you, the issue of the first thing what we face is basically a database. So we don't have a database. Like data set, what we find out is not even a single data set available in like in a many different times. Like we have a very very vegetables understanding. Like if we are tomatoes or potatoes, we know how much calories and everything we have. For example, banana or apple, we definitely know it. So the largest data set, what we figure it out in a open source is a Canadian food nutrient data set or USDA food consumption data set, which are the most common information related to the food and nutrition fact. But the limitation is that it doesn't include chicken masala or penne arrabbiata, right? Like, um, if you're a fan of Italian food, how you even understand the Hawaiian pizza or penne arrabbiata or lasagna, different flavor of lasagnas and the calories and the nutritions of it. It's extremely hard to get all this information. So it means that the data set is extremely limited. So what we did is that we basically go through as many as data set is possible, go through as many as open source data set and collect them all and build a new data set which has the most common and diverse information of food, like from Arabic food to Asian food to Russian food to Indian food to US, Europe, North America, South America, Mexicans, Caribbeans, African, all kind of food. We are trying to get all this food information, put that thing in a one place, clean the data, standardize the process, and we also go through all the websites, scrap the data, and get all the stuffs. So we got some of the stuffs. We create the data set. The question is that how good this data set, and the results are surprisingly nice. So if you see here, so this is the data, this is the statistical graph of the newly created data sets, like vegan versus non-vegan food data set, right? So how much energy it is, or calories it is, or a carbohydrates it is, or like food count it is, right? So now this is very interesting thing. You can see here in a top, on a first corner on a carbohydrate manner that number of uh, number of non-vegan has a higher carbohydrate than a vegan one, and the perspective is going on in terms of energy and other stuff. So it aligns with the understanding of the food as well, which is the very common understanding, like how much energy we'll get it from a specific type of food. So that is very surprisingly nice. It is open source data right now. So the second things what I explain is the phrase detections, right? Like the algorithm present in previously is one of the limitation is the inability to understand the phrases of multiple words. Just an example, like let's understand through one tweet examples, right? You are the apple of my eye, right? When I say you are apple of my eye, I'm trying to adore you, right? Like I try to say you are the most favorite person of my life, right? But the question comes in that how we try to understand that thing. As a human, I know what the phrase means, apple of my eye, but how we want to teach a computer to understand that apple of my eye means administrations, or we are trying to say that you are a most favorite person, but how we teach this thing to a computer. So that's where the things come. It's like we have to extract those phrases and try to understand like what that thing means. For example, I saw the sweet potato. I have to understand that sweet and potatoes are a different thing. Sweet potatoes is a different thing itself. It's a different kind of food. Like we call it sakaria in Gujarati. So we have to figure it out in a way that we extract those phrases. So we develop the algorithm to extract all the phrases from that machine learning algorithm for that. So this algorithm is in detail understanding how new algorithm works and everything in a research paper. But even there are the countless number of attempts already done before that. So what we try to do basically is that we totally focus on a food thing. Like the algorithm, machine learning algorithm, what we created is totally focus on a specifically food phrases detections and the similarities. So it may not work on other things, but it's open source, so you may want to try, or please feel free to try that algorithm. So it is based on a boundary base, how that basically algorithm works. So in a previous one, like they use the boundary based multivariate expressions, or they use the next possible word pair through the probability theorem of the frequency of the word. The third thing is that low end of data set of super science or unintended tweets or semi evolution level, right? The question comes in that how good these things are, right? So what we did is that we train our own data based on our new data set what we have. We already, as I told you, we already created the food data set, which is really nice. So we try to use that type of data and try to create a new model which is totally focused on a food. So we take the raw data and cleaning happens store somewhere. So we want to create the feature engineering specifically for that. So what we do is that we get the face attractions and we get the TF-ID feature with the phrase. So basically what TF-ID do is that is like a frequency based terms, like how many frequency of specific terms is repeated on a statistical level to figure it out that okay, these phrases in a combine means something. For example, apple of my eye. So apple and an eye is basically a phrases, right? Which comes together in a certain frequency manner. If in that frequency manner the sentence falls, we definitely know that they are not talking about the apple, but they are talking about something else. So we train the TF-IDEA algorithm for that specific frequency based on a three. So what the frequency we choose is basically three. Three means the maximum number of phrases are a three. We remove the non-phrase word though, to be noted here. So based on that algorithm, we train that thing with our new food data set. And then after getting all that informations, we put those information like all the phrases as a feature, as a values that if this comes in, we know that thing it is not a food, but it is expression. If that for example sweet potato comes in, we know it is they are talking about the food. So we consider that the specific feature like a TF-ID feature or a phrase extracted phrase as a feature, and tell them okay, based on this feature, the value of the tweet which contain a sweet potato, they are talking about a food. For example, you are an apple of my eye, then apple of my eye is a word and it go to 3FID, use that thing as a feature, and based on the features we can say we can train our model that okay, this is not in this suite it is not talking about the food, but they are talking about something else, so it is a false thing, right? So we try to train the model and create a one predictive model which can tell us that okay, this specific things is regarding the food, or this specific tweet is not regarding the food. So it's a binary classification of the tweet, like it's related to food or not, but it gives the understanding, so we exactly know what we need to extract. If we are sure that the tweet or the sentence is talk about the food, we just use that sentence to count the calories. And if the sentence say it is not about the food, we don't count the sentence, we just ignore that specific tweet or a sentence. So it just give us the clean data to understand and understand the data, that and the result will be more clear and with a very less noise. So what different type of models and models we tried Neobius, linear regressions, random forest, CNN, RNN, GRU, and SVM, and all those things. We figured out random forest works for best for us in this binary classification of these things. So we go with that, and we decided that that tweet is related to food or not. The question comes in that how we wanna count the calories on that. So this specific algorithm we design to extract the word from the tweet when we are 100% sure in an algorithmic way, means that when our predictive model says that that tweet is related to feed, we're trying to figure it out which word it is talking about. We extract the food and try to count the calories of that food, and then we try to save that thing based on different things, based on a province, based on cities, based on national level, and age group, and other informations as well. So the second thing what we do is that counting calories based on that. What is counting calorie is that here is that based on activity. For example, so here we need to understand we're not only counting the calories here. When we say how much calorie consumption is happening, we need to understand that it is not only about the calories what we gather, but it is also about the calories what we burn, right? So the thing is that if I am doing a running and if I am eating 2000 calories, but if I am running for a half an hour and I'm burning maybe 100 or a 150 calories or a 200 calories, the consumption of calories what I have per day is only 1800, not the 2000 calories, right? So to give the data more perspective in a real life way, because in real life we just don't eat, we also do the different kind of activity. We may go to gym, we may do a swimming, we may go to play cricket or a badminton or xyz thing, right? We may go to trekking or running. So we also have to consider this type of things on a larger scale. So this is specifically for that, to understand what how much calorie I'm burning through the activity, and based on that we're trying to find out what is the ratio seen as C out. But the ratio is not on a one number. It is summation of C in a C out based on a different categories like a province, city, or a nations, right? So the results what we get is very amazing. So here is one small result from that research is that Canadian tweets on a like when we see what all the Canadian tweets on a food level in a different province. So just for understanding, when I talk about the province here, province means the states what we have in India. So when I talk about the pizza, right, which is the most common phrase in Ontario, it's in orange on the bottom right. So so the most common word tweeted or spoken on a tweets is pizza. So that's a amazing thing. But if you see next to that in Montreal, it's a fries, and it's no surprise because poutine is one of the inventions done by the French, and it's also the Canada's national food, which comes there. So very amazing fact. If you go on a little bit left to the Ontario, we have a coffee and many other stuff. So that is very surprising results what we got from our tweet analysis. When we see the activity, that is also surprising because it says Ontario to the watching here. And it is also not surprise because from both of the informations, we can say that the caloric ratio of the tweets are really high in Ontario. It's definitely higher in some other region, but it is quite high in Ontario based on the populations. Um, so the results what we got are surprisingly amazing. It also aligned how the Canadian government health department published their reports, like how the trend is going on in terms of obesity, in terms of physical fitness, in terms of food consumptions, in terms of physical activities individual doing on a larger scale in that specific province. So this result is also aligned with what the government shows. So when the result combines, we can confidently, with a caution, can say that this type of systems may work, and it need to be improved, but it is an alternative to a door-to-door stop survey. What is the current and a most traditional and one of the oldest way to collecting the health informations around the globe in all the nations, right? So, what is the conclusion here? The conclusion is that the high performance machine learning model with a very limited amount of training data is still a limited, because it's not even a 1 billion data what we use. We just use a 250 million tweets. So, and the data is between 2017 to 2018. Right now, that amount of data what we have is almost close 3 or 4 billion tweets. So the amount is extremely large, and but the model which we can create with a very small amount of data and train that and use that thing on a large scale is possible. And even the accuracy of the model in a binary classifications between the food and non-food weight, our algorithm shows is 93.404 accuracy from the 250 million tweets data set. So that is quite surprising. Like compared to the data what we have and the model we train, it still works very brilliantly in that manner. So research also shows the social media analysis on a large scale with the better use of NLP algorithms and combination of NLP algorithms, understanding and removing of the noise through the NLP. Like NLP is not only the way to understand the data. NLP can be a way to remove the noise of the data. For example, that's what we try to understand. It's one of the concepts we also trying to drive through the NLP is that, most of the research why we use the NLP algorithm is basically to understand that we some specific type of informations we try to on or try to extract from the text in a different format, in a phrases, on a single word, on a sentence, on a paragraph level, on a maybe a predictive type of phrases detections as well. But we can also use NLP algorithm to remove the noise. For example, here that's what we did by removing non-food tweets from the food tweets through the phrases detection algorithms and many other combinations. So that is the one kind of approach we use NLP, not only for the detection but also for the removal of the noise as well. It also helps us to gain a very larger perspective on our daily activities, not in efforts on a people health, but on the results and convey a complexity relation between the health and the social media. It also shows that people do share their personal habit of doing an activity or eating or liking of a food or a specific recipe, and based on that we can understand on a larger perspective how it is moving on. The presented approach is faster, way faster, I would say, compared to the traditional survey method using, causing the data to be readily available, as well as the close representations of a real time, because this system is updated every second and can give a result as short as 1 day notice for the data analytics. So uh, the amount of time which is usually, if we see the service, it normally takes us 6 months. Gather the data, clean the data, collect the then pre-process it, statisticize and normalize the data, and then submit to the government, and then government will decide that thing. But in this approach, we collect the data, we just show the dashboard, and every day they can see how the trend is going on, and then every time they can see at least the statistics, basic statistics, every second updating on their dashboard. So it is way faster, and way faster representations of the data and analytics on a real time here. So the future work. Now the things come here is that uh, what we can do to make this system more robust, and what the changes we can do, uh, so the government can gain a trust to use this kind of systems, alternative than what they are currently using traditional way. So the first thing is that we have to use more dynamic way to calculate calorie, not only based on what we eat like a food. We can also add the age or a gender or a work profile, right? For example, if anyone is doing a work in a constructions, they may definitely need more than a 2000 calories, right? If he's a boxer or a professional wrestler, he may need more than a 3000 or 5000 calories, right? But if I'm an IT guy who is sitting in my office, not doing exercise, may need only 1500 calories. But I am IT guy and I may go to the gym for a 2 hours. Then I may need a 2000 calories. So work profile, age, gender, and many other things we need to um, uh, put in a single formula and calculate the calories to understand the calories on a very better and very normalized level. The second is the limitation in the when our model looks at the weight. It only recognizes the food, but it doesn't. But it leaves out the quantity of a food. So, just for an example, as I've shown here, uh, the model can say that thing that you are apple of my eye is not about the food, and sweet potato is about the food, or only apple, or a red apple, or a green apple is about the food, but we are not able to identify how many apples are that. Like for example, like I eat three dishes of pulao, I eat a three dishes of dal bati, for example. Number of the quantity of that food is still still hard to identify in a tweet, in a sentence, and it's still a future work to give a more normalized and statistically correct caloric values on a larger scales. So on the end of the presentations, right, you can go to this GitHub repositories where you get the algorithm, machine learning algorithm, which is open source. And there is a research paper link as well, which is available. So you can go to the Google Scholars, download the research paper. It's free to download. It's published in a Springer journal. So please, any questions on a presentations, or any questions regarding any ideas to improve, anything will be welcome to you. Thank you.
Hello.
Hello.
Yes, done. आपका होगा?
Yes.
So thank you so much, Neil, for giving the wonderful session, and and thank you for accepting our invitation. So thank you so much.
Thank you so much for giving me the opportunity to share my knowledge and everything. I love the all the arrangements and everything. Thank you, PU, again for this wonderful opportunities, and I'm looking forward for the another webinar and seminar with the great audience
Sure,
and
sure.
with the team as well.
Definitely, we arrange the next webinar. Okay. Thank
Yes,
you so
thank you.
much.
Thank you. Thank you. Have a good day. Take care.